So for this video lesson, we're going to be graphing absolute value functions, but let's find out what an absolute value function is. When we're talking about absolute value, we're talking about the distance from zero. So an absolute value of a number will always be positive since the distance from zero will always be positive. Let's do this first example. And before we do that, these lines are called your absolute value sign. So these lines right here are our absolute value. So in this example, we say the absolute value of -3. So if we have 3, we want to look at the distance from 0. So the distance from 0 would be 3. Now the same thing with +3. +3, the distance from 0 is also 3. So notice how no matter what sign the 3 has, the distance will always be our +3. Okay, let's go ahead and graph it. We have y is equal to the absolute value of x. When we look at the absolute value of x, we're actually talking about the parent function of the absolute value. So to graph it, we're going to be using or beginning with the table. So I'm going to start with -3 as my x. We're going to go -2, -1, 0, 1, 2, 3, get enough points so we can graph. Then in the middle column, we're going to use or apply our rule. So in this case, we've got the absolute value of -3, which is the distance of -3 from 0, and that gives us 3. Then the absolute value of -2 is 2. The absolute value of 1 is 1. The absolute value of 0 is 0. Absolute value of +1 is 1. Absolute value of +2 is 2. Absolute value of +3 is 3. So I'm going to write these x's and y's as a point. So my x is -3, my y value is 3, x is -2, my y is +2, x is -1, my y is 1, x is 0, y is 0, and then we're going to continue. Okay, so now we're going to plot our point. Since we're sketching the graph, we want to look at the highest x and highest y value, and it looks like it's 3, so I'm going to make it where we have 4 on each side at least, and then we're going to plot our points. So -3, +3, -2, +2, -1, +1, 0, 0, 1, 1, 2, 2, 3, 3, and then we're going to connect our points. So if you look at the shape of the absolute value function, the shape is a V. So now we're going to be looking for the key features. If we look at this point right here, that is our vertex, also known as a minimum or maximum point, and that vertex is located at 0, 0. Now we're going to look for now we're going to draw our axis of symmetry. Remember, our axis of symmetry goes through the vertex, and our equation always starts with our equation always starts with x equals, and because it's going through, so our axis of symmetry always goes through the vertex, and our equation starts with x equals, and since it's going through x equals 0, my equation for my axis of symmetry is going to be x is equal to 0. And now to find our domain and range. For domain, if you recall, your domain is your x values. So what are the x values that are being used in this graph? And a way that we can find the x values is we look for the furthest point to the left, and because there is no furthest point to the left, we know we're going to go to -infinity. And then we do the same thing on the right. Furthest point to the right, there is no furthest point to the right because it goes to infinity. So our domain will be -infinity to infinity. And when we write it in interval notation, infinity will always have parentheses. So now let's look at the range. Range is my y values, so we're going to look at the lowest point. And if we look for our lowest point on this graph, it is 0. And the highest point on this graph, there is no highest point because it goes to positive infinity. So for my range, it's from 0 to positive infinity. Infinity always has parentheses, and because there's a solid point on that 0, we have closed brackets. So it's including the 0. Now when we look for the x and the y-intercept, the x and the y-intercept are the same as my vertex. So my x-intercept is where the graph crosses the x-axis, and that's at 0, 0. And my y-intercept is where the graph crosses the y-axis, and that is also at 0, 0. For the second example that we're going to graph, it's going to be f of x is equal to the absolute value of x plus 3. So because my rule is x plus 3, we're going to put our rule in the middle. And for the x values, because I want you guys to see a nice graph, we're going to use x values of -6, -3, 0, and 4. When we start using transformations and looking more into the equation, which is on Friday, which is sometime next week, you'll know what x values you will need to use, but for right now, I'll give you the x values to use. So I'm going to set up my rules in my middle column. Whatever x is, I'm going to add 3 to it and get the absolute value. And then this -6, plug it in here. So -6 plus 3 is -3, and the absolute value of -3 is +3. Plug in -3 here. -3 plus 3 is 0, and the absolute value of 0 is 0. We have 0 plus 3 is 3, and the absolute value of 3 is 3. And then we have 4 plus 3 is 7. The absolute value of 7 is 7. So we're going to go ahead and write our points as coordinates. Now that we have our points written as coordinates, because our largest number is 7, we're going to label our x and y axis up to 8. So once you plot those points, we're going to connect them. And as you can see, it has changed from our original graph, our parent function, and we'll talk more about that when we get into transformations. So now let's go ahead and identify our features. So the first one would be my vertex. So my vertex is either the lowest or highest point. In this case, it's the lowest. So my vertex is at -3, 0. And then we want to find the axis of symmetry. Remember, your axis of symmetry is that vertical line that goes through the vertex. And the equation of the line always starts with, and it's x equals whatever number goes through on the x-axis, and that's -3. This is my axis of symmetry. And then we're going to look for our x and y-intercept. My x-intercept is where the graph crosses the x-axis, and that's at my vertex, which again is at -3, 0. And then if we look at my y-intercept is where the graph touches the y-axis. That's going to be my y-intercept right there. And that point is at 0, +3. Also and now for the domain and range. So domain again is your x values. So we want to look for the furthest point on the left to give us the lowest x value, and that is negative infinity, because there's an arrow, it goes on forever. And now we want to look for the point to the most right. So now we want to look for the point that's furthest to the right, and there is no point furthest to the right because it goes on forever because of this arrow up here. So this is going to positive infinity. So my domain is -infinity to positive infinity. And in interval notation, we use parentheses because we have infinity. We never include infinity. So now we're going to look for the range. The range is your y values. Oh, sorry, so your range is your y values. So we want to look for the lowest point on the graph, and the lowest point on my graph is 0. And then we want to look for the highest point on my graph, and because there's arrows, we have no highest point, so that's infinity. So we're going to positive infinity. Infinity will always have a parentheses, and because we are including that 0, we have a bracket. All right, you're going to go ahead and do the decimals activity, where you will be identifying key features of absolute value functions, and then you'll move on to the transformations activity on decimals as an introduction.